And I just want us to think about what we have done so far in this pipeline. So we had a data set with missing data. We created a train test split, and our train data had missing values, so did our test data. And so we just removed the cases with missing data from both, such that we had training and test data with dropped cases. And we built a prognostic model that was predicting death using age and BP. And we saw that on training data, we got high accuracy. On our test data, we got high accuracy. And on our new test data set that came along that had no missing values, we just ran the model straight on it and it got a low performance. So why might this be happening? So we know that one reason that we can see this discrepancy between the training data and the test data, or even the old test data and the new test data, is that the distributions are different. So let's try to test whether their distributions are actually different. So one way we can do that is we can look at the distribution of the input variables. Here we'll focus on age first, but let's say if we had lots of variables, we could repeat this analysis with multiple other variables as well. And so on the left, we have our old or our original test set on which our random forest model got relatively high accuracy, 0.84. And on our right, we have our new test set on which our model got a relatively low accuracy. So let's look at the difference in distribution between the ages. We can see that there is a spike on the older people between 65 and 75, but we see that the main difference between these two graphs is what's happening right below the age of 40. We're going to draw a line there, and we can see that there are far fewer number of patients who have an age of smaller than 40 in our old test set compared to our new test set. So now we can ask the question, is it possible that we're performing really poorly on patients that are younger than 40, but we just don't see it because we just don't have enough examples right here while we have a lot of examples here? And so let's see what happens when we just evaluate on the left and the right hand side of this separating line. So when we look at young patients and we evaluate, okay, we get an accuracy of just 55%, while on the right, we get a high accuracy. And we see the same story here. But what's the difference? The difference is that we have very few patients under 40 here, while we have a lot of patients under 40 here. So our low accuracy actually has a higher influence on our total accuracy here.